It's also sometimes referred to as the XY plane. And really, this is something that was really transformative in terms of both industry and art. In industry, we could now make parts that were more standardized because they could be scaled appropriately in an accurate manner in a drawing, and two people could produce very similar objects. Up until that time, anything that was made was completely one of a kind, handmade. As far as art, if you ever have seen earlier paintings, when they were attempting to make the subjects look the way they were supposed to look, everybody looked sort of flat, almost like they had been run over by a steamroller. Everything looked very flat. With this Cartesian coordinate system, we started to get the idea of perspective drawings. In non-pandemic semesters, you've likely seen students in the hallways working on those, sitting at the little desks, making sort of 3D representations of our hallways. But really, boiled down to its most basic, these really are just a pair of number lines that meet at a 90-degree angle. So the domain number line is generally the horizontal. So remember, that's the independent. Generally X, but occasionally also T. And the vertical number line is your range number line. So that's your dependent variable. And generally that will either be a y or an f of x or something specific to the problem that you're working with. But really that's all it is. The place where these two meet is referred to as the origin. And then we have our quadrants. So you might notice these two meeting like this cut my page into 4 sections. We call them quadrants. So quadrants. So this is Q1, quadrant 1, and we count counterclockwise. Quadrant 2, quadrant 3, and quadrant 4. And the number lines are referred to also as axes. So this would be the x-axis, the y-axis. So as far as locating points, we won't spend a ton of time on this since we tend to already cover that. Everywhere in your XY plane, and I'm just going to use a little stamp to save us some time. You can create a fairly accurate graph at home using just really a ruler and marks either each centimeter or each ½ inch. You'll get decent graphs that way. So each of these points on here can be located using 2 numbers. So if we make that point A, it's always an ordered pair. Your independent and your dependent in that precise order. Your X and your Y if you're using the brand name X and Y. So from the 0 on the number line for the domain, we went to the right 1, 2, 3. And for the output, we climbed up 1, 2. The order does matter on that. Point B here, on the domain number line, I would go to the right 2, so the positive direction is to the right or up, negative is to the left or down. My output, my range variable, takes on a value of 3. So the order does matter, hence the name, ordered pairs. Now, as far as graphs of, we're going to stick to functions. We're going to still look at our domain being the set of integers. But all a graph is a picture of solutions to an equation. So it's just a picture of the answers that'll work for a particular problem. So we'll start with f of x is x squared. So I like to kind of start at 0 and work my way out from there. So f of 0 is 0 squared, which is an output of 0. So our ordered pair would be 0, 0. This would go through the origin. If I have an input value of 1, f of 1, 1 squared is 1. 1, 1 is on my graph. 2 is where the behavior starts to become apparent that it's changing. 2 squared is 4. So instead of 2, 2 like you might have expected on these last couple, now we're up to 4. 3, f of 3, 3 squared, which is 9. 3, 9 should be on our graph. Now, generally for this course, I'm going to stick to -10 to 10 for sketching graphs. Most of them will be on -10 to 10. That's what my little stamp does. That's what the printed graphs on your tests will do. That's not to say that always has to be the rule. We can have these go to 10 million and to 43 million. We can scale it however we want. But generally, for this, we go -10 to 10 in either the horizontal or vertical directions. So f of 4, 4 squared, positive 16, 4, 16 takes us off of there. So then I'll start moving on to integers in the other direction. So -1, f of -1, -1 quantity squared, which is a positive 1. So -2 squared, negative times a negative, would kick us back over to a positive. So this should also spit out a 4. Trying out a -3, we should get a positive 9. So the graph, I would just plot those. And I'll do these in red just to make them stand out a little bit from the black. So we have 0, 0, 1, 1, 2, 4, and 3, 9. We also have -1, positive 1, -2, positive 4, and -3, positive 9. So in red here we have the integer domain graph. You'll often see our author kind of connect them with a curve. So once we expand the domain, the blue will also be part of the graph as well. But it also does nicely kind of show us the pattern as well. So that's our graph of f of x is x squared. In general, if you see an x squared involved and no other variables in a denominator or anything strange like that, you're going to see this U shape. So x squared, think of a U shape. It's called a parabola. A lot of students just call it a U shape. Either one helps us identify what we're referring to. All right. So next up, we'll take a look at g of x is the square root of x. Square root, we have to pick our numbers a little bit more carefully than we did with the square if we want to stay on these nice, neat, pretty corner points. So again, I'll start with 0. So g of 0 is square root of 0, which is an output of 0. So this too includes the origin. Drawing out a 1, g of 1, square root of 1 is just a 1. So this one also goes through 1, 1. That's why you need a lot more points than you used to have when you were just graphing lines in your Math 95 or the equivalent you took elsewhere. Now, here's where we run into a little hiccup as far as wanting to work just with integers. If I try out g of 2, square root of 2, remember that is one of our irrational numbers. So this one is not a nice, neat, pretty corner point on the graph. 2 and root 2. Root 2 is about 1.41, but this is, recall, root 2 is not an integer. 3 also would not spit out a nice, neat, pretty corner point, but 4. 4 is a nice, pretty, perfect square. So g of 4, square root of 4, which is an output of 2. So 4, 2 should be on our graph. See if you can think of what the next nice, neat, pretty, perfect square would be after 0, 1, and 4. Okay, hopefully you figured out 9. G of 9, square root of 9, which is worth 3. So 9, 3 also should be on our graph. Now recall, if I try to go in the other direction, g of negative 1, square root of negative 1, not a real number. So this one cannot go in the negative direction. So when I sketch my graph here, again, I'll do this in red. So we have 0, 0, the origin. We have 1, 1, just like the y equals x squared graph had. 4, 2 was our next corner point. Then I had to go all the way to 9 to go up to 3. So this time when I draw my curve, I'm only going to move in the positive direction. So we have this curve that is moving up and right as we go. Nothing happening back here. I do not extend it to the left here. We've been kicked out of the real numbers if we go to left, and this is just a pair of real number lines. And again, as far as shapes, if you see a square root involved, you should see this kind of shape. Maybe it'll open up, maybe it'll open down, maybe it'll open left, maybe it'll open right, but expect to see some version of this shape. Same thing with our previous one, the square function, our U shape could be upside down. That is possible. So next up, we'll look at h of x is absolute value of x. So again, I like to start with the 0 and see what happens there. So h of 0, absolute value of 0. Absolute value of 0 is 0. Remember, absolute value is a distance, but it's a distance from 0. So again, we have the origin. h of 1, absolute value of 1. Absolute value of 1 is 1. We're 1 unit away from 0. 2, h of 2, absolute value of 2, absolute value of 2 is 2. 3, h of 3, absolute value of 3, which is 3. And I don't see any reason why this pattern wouldn't continue. So we have 4, 4, 5, 5, 6, 6, etc. So let's see what happens in the negative direction. H of negative 1, absolute value of negative 1. Negative 1 is also 1 unit away from the 0. So we have negative 1, positive 1. If I try out negative 2, h of negative 2, absolute value of negative 2, which is positive 2. So we have negative 2, 2. Negative 3 works the same way. H of negative 3, absolute value of negative 3, which is positive 3. So negative 3, 3 should be on our graph, and this will continue. So we have the origin, we have 1, 1, 2, 2, 3, 3, and we said that pattern would continue. So I have 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. Going the other way, we have negative 1, positive 1, negative 2, positive 2, negative 3, positive 3. And we said that pattern would continue. So we have negative 4, 4, negative 5, 5, negative 6, 6, etc. So in red here, again, I have the integer domain graph. If we look at the pattern, though, that's going to be our real number domain graph as well as the pattern. So this one would go up and right or up and left, both directions. So when you see an absolute value, you're going to think a V shape. So if you're plugging in some numbers and you just get a line segment, keep looking, keep going until you find where it bounces. That's worth making a little note of. I'll call it the bounce. So we have this nice, neat 90-degree angle for coefficient of 1 on a linear absolute value. So absolute value of a linear. The graph, as you can see, is nonlinear. So again, that's just something to look for. I wanted to look first at just one thing at a time happening to it. Let's see, I want to look at one more of these. We're going to look at one rational function. And then we'll try some out with some other things happening to them. So we'll try out f of x is worth 8 over the quantity x minus 1. So again, I like to try to start with 0 where I can. So f of 0, 8 divided by 0 minus 1, which is 8 divided by negative 1, which is a positive 8. So we have the ordered pair 0, 8. If I try out the 1, f of 1, you should have alarm bells going off in your mind. Undefined, so we have no ordered pair. Let's try out a 2 though. F of 2, 8 divided by 2 minus 1, which is 8 divided by 1, which is a positive 8. Let me fix my sign there. So we have 2 and positive 8. Let's try a 3. F of 3, 8 divided by 3 minus 1, which is 8 halves, which is a nice pretty 4. So 3, 4 should also be on our graph. If I try out a 4, 4 minus 1 is 3. 8 is not divisible evenly by 3. But if I try out a 5 next, f of 5, 8 divided by 5 minus 1, 8 fourths is 2. So 5, 2 should be on our graph. Let's see. After that, the next number that 8 is divisible by is 8 itself, which I would have to plug in a 9. F of 9, 8 divided by 9 minus 1, which is 8 eighths, which is a 1. And that's as far as I want to go in that direction, so we'll start moving the other direction. If I plug in a negative 1, f of negative 1, 8 divided by negative 1 minus 1 is 8 divided by negative 2, which is a negative 4. So negative 1, negative 4 should appear on our graph. Next, I'd look for how I can get a negative 4 there in the denominator. That would be plugging in a negative 3. F of negative 3, 8 divided by negative 3 minus 1. 8 divided by negative 4 is negative 2. So negative 3, negative 2. And then I'm going to ask you to take a moment and figure out what number you would plug in for x to get a negative 8 in that denominator. Okay, hopefully you figured out negative 7 fits the bill. So negative 7, negative 1 should appear on our graph as well. All right, I'm going to try and squeeze this guy up in the... Yeah, I'll just fit him as best I can. May have a little bit of overlap there, that's okay. And again, I'll do these in red and the pattern in blue. So we have 0, negative 8. Left and right 0, down 8. For some reason, when 0 is involved, is when I see the most mistakes of accidentally going left 8 and up and down 0 Remember, the order still matters. Left and right 0, so stay parked where you are, then drop down 8. We had nothing happening at 1. You'll see why in a moment. I'm just going to draw a little dotted line there. At 2, we have an output of positive 8.